All right, guys, welcome back to another day where we're building the snake game. Today we're going to take care of the actual snake. So we're going to build a chain of body parts together, get them to move, get them to follow each other and follow the head, and eventually get it to crash into walls, top, bottom, left, right, or into itself. So this is the more complicated of the classes. This also deals with one of the things that I talked about yesterday in compositional relationships, where we're going to have a object that consists of other objects. So the snake is an object we're going to make, and it's going to have lots of body parts in it. So we're going to create a list of body parts to kind of put everything together. So we'll kind of carry this through again in person. This would be a lot better than on video, but I want you to do the same thing we did yesterday, where you pause the video when I say to pause it, and then go ahead and fill out as we go along, and you'll be uploading your snake file to the assignment that this video is posted in. So first thing I'm going to do is I'm going to create a new file. I'm going to call it the snake. Okay. So if you're an idle, you can do a file save as real quick and just talk snake.py. All right, let's get into this. We'll get our import statements going and what we'll need to do. So now, since I'm going to import what I did yesterday, I don't need to make the same imports again. So I don't need to import graphics, because when I import the body part, it's going to come with graphics, because graphics imports, or body part imports graphics. So I'm going to do from body part import star. Now remember, this is the name of the file that you have. So if you called it something other than body part, you got to make sure that you call it whatever your file name was. All right, so let's get into this. First thing we're going to do is make our class definition for the snake. Okay. Snake is built based on a list of body parts. So let's get into that. Our constructor def init. Now for the snake, what I'd like to be able to do, I need self here. I also need to make sure that I pass in an X and a Y. So I want to tell it where the head is going to start, because maybe I want to start it in a random place, or I want to start it in the center of the window, or whatever it is, and make the window different sizes. So I want to be able to tell it where the head is going to be, and what direction it's going to be going in. The rest of the information for body part, we'll just make it up as we go. That's why we defaulted quite a bit of it. So we're going to go direction. I'm going to make that equal to north right off the bat, just so that it's defaulted into something. Okay, so let's come up with our attributes for the snake. They don't have to be the same as the body part. Each body part will keep track of itself. The snake itself is what I'm worried about. So I'm going to go self dot underscore x equals x. This is going to be the top left corner of the head. That's the most important piece. The head is what's going to run into stuff first. It's going to hit a wall first, or it's going to hit another body part, or it's going to hit a mouse eventually. And then it'll elongate the snake when it does. So I'm going to go self.x is x. I'm going to go self.y. Okay. We'll do the same thing with direction, self.direction. Okay. Also, another attribute is self.alive, whether or not it's still going or not. So it's going to stay alive until it does one of two things. It crashes into a wall or crashes into itself. So this is just going to be a Boolean attribute. I'm going to say it's true off the bat, and I'll turn it to false when it does crash into something, and that will stop my game. That's what I want to continue to do. The other parts that are part of this is self.__ body parts. Okay. And that is going to be equal to a list. That list is going to have a lot of body parts in it. So objects from the body part class. This is the compositional piece. Now, when I do build a snake for the first time, I'd like it to have a head and maybe a couple body parts. Now, that's going to be a little much for me to code in the constructor. So you know what I'm going to do is I'm going to pull a trick from the rational lab, where we call a method in the constructor that can help us build the object, like the reduce method we called. Here, I'm going to go self.create. That's a function. It's going to be a private function, because I don't want to create the body anytime else other than creating a snake. So I don't want this function to be accessible from anywhere else other than this method right here. So this, we'll write a quick comment, is going to be a list of body parts to build the snake. This right here is going to be a function to build head and all initial body parts. All right, So I think we should start off with that function right here, that create body. Okay. We can call toString methods from any of the body parts, including the head. So we may not need one for this particular class. So I don't think it's worth putting in, to be perfectly honest with you, but we could if we want. So I'm going to go def create. Actually, why don't you do yourself a favor, pause the video right here and make sure your constructor is filled out. Once that's done, come back and we'll finish out the create body part. So def create body. Okay, there's the function. This function is simply going to create and append information into that list that I have. So first of things first, I'm going to make the head. The head is a body part. Okay, to create a body part, I need to tell it where to go. So we're going to say self.x, self.y. Okay, so I want the head to be the same self.x, self.y as the snake because the head is going to be the lead piece. Now, remember, a body part also needs a size, a color, and a direction. Now, I don't want to change the size and I don't want to change the direction, but I would like to change the color. So the only way to change that without putting in a size and a direction is by keyword argument. So what I'm going to do is I'm going to go color equals, I'm going to go color underscore RGB, and I'm going to put in a different color. It's going to be 255, 55, 0. That's that nice orange color that I have for the head. So that's going to change the head, and what I'm going to do is I'm going to append the head to the body parts list. So self.bodyparts.append the head. So that will get the snake so that it at least has a head. But I would also like to have other parts behind it. So I know it's facing north. I want to build a couple body parts south of the head. So what I'm going to do is I'm going to come up with a quick for loop for I in range. And let's just make like 3 parts. Or like 2 additional parts or whatever we want. So what I'm going to do is I'm going to start this at 1 and go to 3. This will create 2 additional parts. Now the reason I'm going to start at 1 is because I need this counter as a multiplier to kind of help me place these things behind it. So watch and see what happens with this. So I'm going to say new part equals a body part. I construct it. Now I need to give it an x and a y coordinate. Now the x coordinate, since I'm creating these parts south, directly underneath the head, I don't want to change the x coordinate. The x coordinates are going to stay the same. So I'm going to go self.x. That's going to be the x coordinate for each one. Now the y coordinate is going to increase each time I create a new one based off where the head is. So the first body part under the head needs to be 20 pixels below where the head was. The second body part needs to be 40 pixels below. The third one 60. The second one 80. And so on and so forth. So you see that every time I add another body part, it increases how far below the head it is by a factor of 20. So that's what I'm going to write. I'm going to say self.y, okay, plus 20 times I. And that's the reason I have I in here, is so that when it is a particular value, I can use it as a multiplier for how far down I want it to be. So when I is 1, okay, because it starts at 1 times 20 makes 20. The first body part is 20 pixels lower than the head. When I becomes 2, 2 times 20 makes 40. So now the second body part is 40 pixels lower than the head, and so on and so forth. So just a little bit of math that goes into these games as you're building them. So that's the first bit. Now every time I create the new part, I need to put it in the body list. So self.bodyparts.append the new part. Okay. There we go. I have a snake made. Okay. Not a whole lot I can do with it, only because I can't see it. But go ahead, pause the video at this part, make sure your create body function is exactly what it is for me, and come back to the video when you're done typing it out. The next part that I'm going to do is I'm going to write some get methods like I had before for these pieces that are private, and the draw method. So we'll go through those 3 off the beginning. So first thing I'm going to do is I'm going to write those 2 get methods, which are going to be right here. And I already have get methods for body parts, so I can access those pretty easily if need be. So there's going to be my get methods for the direction and the get methods for the body parts list. Now I can always get information from each body part itself as well if I need to. Okay. Next thing I need to do is draw each body part, so that will draw the snake. Here, that method is actually really simple to write as well. I'm just going to copy and paste it in here. It is the same as the draw method from the body parts class. It's just I have to go through all the body parts in the list to do it. So my draw method here passes in a window object, and I loop through all of the parts in my body parts list, and I told each part to draw itself, since each part is a body part. And if you recall, every body part knows how to draw itself. I can access this method right here, if I can scroll to it, and it will just fill it the right color that it wants to be and draw it. So go ahead, pause the video at this point in time, and get those 3 methods typed in. Those are fairly simple to work with. All right, now that you're back, I think we should create a quick snake object and make sure that it's working appropriately, that we're able to see what we want to see. So let's come down here, and this will be a quick check. I'm going to do Control J, if name is main. I'm going to create a window equals graph win. Call this the snake test window. I'll make it, what, 600 by 600. Okay. And I'm going to make a snake. Make it equal to object. Oops. The snake needs an X and a Y and a direction. We need to give it an XY. So let's just put it at, say, 300, comma 400. It doesn't really need a direction. Well, let's just do snake dot draw. Go ahead and put our wing dot get mouse in there. And a wing dot close. And let's play it and see what happens. Make sure everything's working. And there's my snake. It's got 2 body parts, exactly what I want. If I want more body parts, then all I have to do is come in here and up this loop counter to something slightly higher, like 6. And if I were to play it, I would end up with more body parts. So pretty basic and pretty simple. So go ahead, get that test in there for the time being. We're going to modify that one a whole lot. So if you don't have that in there just yet, that is fine. Okay. But do know that your program is at least working up until this point in time. All right, now some of the more complicated features. Getting the snake itself to move. I think that would be the next piece that we want to do. Essentially, getting the snake to move means we move each body part individually, okay? But the trick is every body part has to follow a body part that it once came from. So let's say I had a snake object that looks something like this. Here's a square, here's a square, here's a square, here's a square, here's a square. And then remember this right here is the head. Okay. The trick is if I turn it to the right, that means that the head then goes here and all the other pieces begin to follow it. Okay. And the next iteration would be this. And so on and so forth. So the trick is getting the last piece to follow the piece in front of it. We only control the head and tell it where to go. And once we know where the head's going, all of the other tail pieces follow the piece that's directly in front of it. So what we need to do is not work on moving the head first and then each body part to follow. What we need to do actually is move the tail into the same direction that the other piece was running. This is going to move the same direction this was running. This is going to move the same direction this is running, and this will move the same direction the head is running. That's the most complicated method, I think, of the whole piece. We know how to move each body part. We just got to tell them which direction to go in. So let's make our move method, def move. Okay. We're going to say self. We're going to pass in a direction. And the window as well eventually, because we're going to get into a whole bunch of collision and things of that nature. So I'm going to pass in the window just to get it started. We may not use it just yet. So go ahead and pass that in there. I'm just kind of foreshadowing what we're getting into. So first and foremost, let's get it into actual start moving and things that we want to do. So we're going to say self.direction, okay, equals direction. Okay, that's going to update the direction of the snake. We're going to go through all the body parts from the back, from the tail to the front, okay, and we're going to tell them all to move based upon the direction of the previous element in the list, the one that's created in front of it. And then we'll move the head at the very end. So I'm going to go for I in range. Okay. What I need to do is get to the last body part. So what I'm going to do is I'm going to go len of my body parts list. Okay. I'm going to -1 from that. You guys know that when you're working with a list, the last item is either at index -1 or it's at the length of the list -1 because the length of the list is not a valid index. We go back 1 to find where the last piece is. That's going to get me to the last body part in the list. I need to run this loop, okay, all the way down, but not including the head, which is why I'm going to put in 0. I'm going to put in a -1 here, so it goes from a big number like 17 to 16 to 15 to 14 to 13, all the way to 0, but not including 0. So that will move each piece from the tail up to, but not including the head, or at least iterate through each one. And all I want to do is tell it to move. So I'm going to go self.bodyParts. Okay, I'm sorry. Self.bodyParts, yes. At I, that's the index that I want to access it at, and I want to tell it to move. Okay. Now remember, the move method from a body part needs a direction. So what we want to do is tell it to go the same direction as the body part in front of it, the previous one. So I'm going to go self.bodyparts.getDirection, or self.bodyparts at I-1 dot get. Mouthful, without a doubt. But if you think about what's happening here, okay, I'm telling the current body part to move, which is the tail piece, based upon the direction that the piece in front of it is already moving. Okay? And since we haven't updated that piece's direction yet to go in a different direction, it will follow it each time. So if it was heading north previously, the body part behind it will head north. If it was heading east, it will head east, and so on and so forth. Now I just need to move the head. So what I'm going to do is self.bodyParts at 0, that's the head, dot move based upon self.direction. That'll move the direction that I told it to, right, that I'm passing in. So go ahead, pause the video, get that in there first and foremost, okay? And then what we can do is kind of test it and make sure that it's working appropriately, okay? Let's come down here, we'll test it real quick. We're just going to tell the snake to move. We'll do a couple mouse clicks and we'll kind of go through this. So we'll go 4, let's just do 4i in range of 4. Just to do a couple things, we'll do a win.getMouse, and then we'll do snake.move, and I'll tell it to move east. Okay, because that's the direction I want it to head. Okay, so let's go ahead and play it. Let's see what happens. Ooh, I did draw the snake. So here we go. And I'm going to click, and I need to pass in a window as well. Even though I didn't use it, I need to pass in the window. My bad. Okay, so let's do that real quick. I'm going to click, and you can see that it seems to be working just fine. If I tell it to move, say, west, okay, run, and I click, and it starts moving, okay? Let's say I do like a win.getMouse real quick right here, and I do a snake move, and I tell it to move north again after each click, something that we can kind of put together. So west, north, needs another argument, sorry, win. Again, you don't have to have this main coded yet. We'll get the code in there for that, just what we want. So now you can see it kind of takes a zigzag pattern, and each body part follows the one that was previously behind it. So the move method is now working. Again, I'm going to take this stuff out because it's just not going to be useful for us later. If you had it in there just to test things, go ahead and test things. You can pause the video and check it out, see that it's working appropriately. Once you've confirmed it, you can go ahead and delete it like I'm about to right now. So pause it, come back, and delete it. All right, now that we have the snake moving, we need to be able to detect whether or not it ran into a wall or into itself. So I'm going to create a method called detect collision. Okay. I'm going to pass in a window here because I need to know if it hits one of the sidewalls. Okay. And the only thing I'm really worried about is the head. If the head goes in a particular spot, then I know that it collided with something. So here's what I'm going to do. First, I'm going to check the 4 walls of the window. If the head goes into or beyond one of the 4 walls of the window, then I know it's collided with something. So I'm going to say if my self.bodyPart at 0, there's my head, okay, dot get x, that's why we wrote those get methods before, because we don't have access to the private members of the body part here. If that happens to be less than 0, okay, that means it went through the left wall. Sorry, the other way. Okay. All I'm going to do is I'm going to return true because I detected a collision. It collided with something. This is true. Everything in this function is true if it detected a collision. So there we go. If, okay, self.body parts at 0, that's the head again, dot get x happens to be greater than or equal to when dot get width. Okay. So if I've gone too far, okay, I'm inside of the window, I'm going to return true. I'm detecting collision. Every time I hit something that it would have collided with, return true. Let's do the same thing with the top and bottom of the frame. So L if, it's an L if actually. L if self body parts body part at 0 dot get y happens to be less than 0, return true. I'm going to say L if, okay, there's not an else situation here because I want to make sure that I'm always checking the condition, okay. Self dot body part at 0 dot get y happens to be greater than or equal to when dot get height, return true. Okay, so all of that will allow me to check whether or not I ran into one of the walls. Okay, we can test this. Okay, so go ahead, copy that method down, pause the video, copy that down. And you know what I'm going to do is once you have that method written down is I'm going to come back up into the move method. And every time it moves, after it's moved, the head is moved and updated, I want to detect if it's been collided with. Now remember, this returns true or false if it doesn't do anything. So what I'm going to do here is I'm actually going to write in one more piece of code and say return false. And that's just going to happen if none of these end up true, none of them. Return false. We didn't detect a collision. That way we always have something to check. So again, I'm going to come back up here to my move method. I'm going to say if self.detect collision with the window. If that's true, okay, I simply want to take self.alive and make it equal to false. I could have done that down here and made just self.alive equals false, self.alive equals false, so on and so forth, but I still have to call this function someplace and then do something with it. So I might as well do it this way. It doesn't make a difference really how it gets done, just that it gets done, and self.alive changes to false at some point in time. Now we can come down here, go ahead and pause this real quick. Again, remember I changed move, just the bottom of it. Go ahead, pause it, make sure you've updated the detect collision and the move method appropriately, and then come back to me when you're done. And once you're done, we can go ahead and we can probably test this. I'm going to save the testing of this for a little bit later when I start putting stuff together. Well, let's just do it now. So what we're going to do to test this is we are going to start trying to get the directions from the keyboard and working our way through that. So let's see. Let's write a loop in here. We'll say while snake not alive. Okay, remember that's true or false. While it's alive, I want it to move. What I'm going to do is I'm going to get a direction. Remember, I can actually use this function from the body part file because we imported everything from the file that wasn't in that main method. So I still have access to this function. Now I do need a window to pass in here and a current direction. Now the current direction is the snake's direction that I want to pass in. And I want to make the snake move. Okay. And I need to pass in a direction and a window. Okay. We'll do a quick time.sleep. And this isn't the best way to do it, but we'll do it this way anyways. We'll show you how we can fix that in a little bit. And let's play it and see what happens. So here it goes. You can see it moving. I am controlling this with the arrow keys right now. Remember that that get direction function is translating everything for us. So now I've got this, and my goal here is to crash into stuff. So you'll see, boom, the snake stops moving at this point in time. I can click and it ends. Okay, so it doesn't really do a whole lot once that happens, but it does work. And if I were to play it again, I can crash into any of the 4 walls that I want, and it will end the game. So you can see it stopped. I can click, it's over, and so on and so forth. So everything seems to be working exactly the way that we want it to be working. Now it's time to just start getting things, some other things going on. So we also need to check to see that it can't run into itself. Because remember, our snake is going to get bigger and bigger and bigger. So I'm actually going to come back in here to detect collision. So find detect collision for yourself. Before you return false, okay, I need to figure out whether or not the head has ran into any of the other body parts in the list. Okay, so what I'm going to do is I'm going to go through and loop through all the body parts in the list except for the head. So I'm going to say if, for I in range, I'm going to go 1 to len of body parts list. Okay. So that's going to get me through all the indices from the first index up to the last index of the body parts list. What I need to do is check to see if, okay, and this is a bit of a long one, self.body parts at 0, okay, dot get x is equal to, okay, self.body parts at I dot get x. If that's true, then I know the x coordinates match for the body part, for one of the body parts in the head. And, okay, I need to check the y coordinates. Body parts at 0 dot get y equals self dot body parts at I dot get y. I'll make this a little bigger so we can see it all in one stretch. Okay, I'll leave the mark down there a little bit. Okay, that's one way to kind of write it to see that it's all in one shot. Okay. So if the x coordinate of the head and the x coordinate of the current body part match, and the y coordinate of the head and the y coordinate of the current body part match, then the head must have ran into one of the tail pieces. If that's true, if that's the case, then I simply want to return true again. I ran into myself, so I ate myself. Otherwise, we return false. Okay. So I'm actually going to get this, yeah, it should be fine the way that it's written right there. All right, so pause the video, get that other part of that function in there, and we'll go ahead and we'll test it, okay? We don't have to call it anywhere because we've already called it. So go ahead, pause it, see where you're at. All right, now that you're back, again, we don't have to call this part of the function anywhere because we've already called this function in the move method. If we detect a collision, we set self.alive to false. We don't have to change anything here because we've already moving it. So let's go ahead and play it and see if we can run into ourselves. So it's going, going, going. I can hit any of the 4 walls, but if I make a really sudden turn into myself, I die. Okay? It'll become more apparent if we made this a little bit longer. So let me go ahead and change how many body parts we have to, say, maybe like 16. And there we go. I'm a little bit longer, and now you can see that my head buried into my tail and the game ended. So it seems to be working exactly the way we want. Everything seems to be going just fine. Now the only other thing that a snake must do is to append body parts to itself. So to make a new body part and put it on the end of the tail. So it's not terribly difficult to do. We just got to make sure that we have everything put together the way that we want. So let's make another function. Append body. Okay. We're going to pass in the window here. And here's what we need to do. In order to append a body part, really what we want to do is add another part to the end of the tail. So I need to figure out exactly where the last body part is located so that I can put it in the right spot. So I'm going to come up with a couple variables here called last x. This is the x position of the last body part is equal to self.bodyparts.getx. I'm sorry, self.bodyparts at -1. whoops, where did I go here? Get X. I'm going to go last Y. Body parts at -1 dot get Y. I also need to know what direction the body part was heading, okay? So that I can create it going in the opposite side of what direction. Because if it's heading north, then I want the body part to be placed south of the last one. If it was heading to the east, then I want it to be placed to the west, or to the left of where that last body part is. So I'm going to go with direction equals self dot body parts at -1 dot get direction. Okay, so now here come some of the questions I have to ask, like I was just talking about. If the direction is equal to north, I want to create a new part south of it. So the new part is equal to a body part. Okay, and I'm going to put in last x, because the x coordinate's not going to change. But the y coordinate is going to be increased by the size of the body part. So what we'll do here is we'll say last y plus, and to make this a little easier, let's just go size equals self dot body part at -1 dot get size. We'll add size here. Again, you're going to pause this at some point in time and put this all together. All right, so there's a new part. We're going to say L if direction equals, say, south. Okay, we want to do essentially the same thing. New part is equal to a body part with the same last x, the y coordinate. We're going to subtract. That way it goes above. L if direction is heading, say, east. New part equals a body part where the last x is then going to get decreased by size, because if it's heading to the east, if it's heading to the right, I want to make sure the new body part happens to the left of it. And the y coordinate will stay the same. Yep, that should be good. And then else new part last x plus size, comma. Okay. We've got our new part created and created in the right location. Now we need to draw it and append it to the parts list. So let's go with new part dot draw the window. This is why we had to pass in the window to the function. And we're going to say self dot body parts dot append new part. That way now it's in the list and it will move with all the other pieces of the list because we wrote our functions to do so. So let me minimize this for a sec. I'll bring this up a little bit. There's your append body method. Pause the video here, get that copied in. All right, now that you have it copied in, let's go ahead and test this method a little bit here. So what I'm going to do real quick, and you don't have to test this just yet, but I'm going to come in here and I'm going to change my create body to just create those first couple of pieces, 1 to 3 to begin with, because we know everything else is working. Now what I'm going to do here is I'm going to just have it create a new body part every so often. So here's what I'm going to do. I'm going to make a counter. This is just testing. Again, this is not the game whatsoever. So I'm going to say counter equals 0. I'm going to say if every time this thing moves, we're going to increase the counter. Okay. If the counter is divisible by 5, so every half a second, okay, we're going to append a body part to this just to test it. So I'm going to go snake dot append body, and this function requires a window object to be passed into it. Check, make sure, yes, a window object. So that should be pretty basic and pretty simple. So if it's divisible by 5, I'll make that equal to 0. We're going to append a body part. Okay, so let's play it. You should see body parts just get added to it so frequently. About every half second, you'll see them get added. We can change this. Actually, let's change it to 10 so it happens once every second so it doesn't get completely ridiculous. So let's run it. You see it running, and a body part got added, it's getting added. Snake keeps getting longer and longer and longer, and obviously you can see it now. Every second, a new body part is being appended to it. And every body part is still working exactly the way that we want. Everything's still moving. Every second, that tail kind of takes a pause, and a new body part gets put on it. And those body parts, those new ones, still act appropriately. They can still detect collisions and do everything they need to do. Okay? So, in terms of everything that we have here, we've got our game essentially built, okay? And everything is tested appropriately. Everything works. We'll just have to make sure that all of these things that we have going for us then make it into our game so that we can use it appropriately. So I'll scroll back over this. You can pause it at any point in time to copy down anything you may have missed. So first and foremost, we have our constructor, okay, which is giving us an X and a Y, a direction, whether or not we're alive or dead. Body parts, and we create body part functions. Go ahead, pause it here if you need to get your constructor filled out. The second method was the create body method. Go ahead, pause it here to get that filled out. We'll talk about it real quick. The head was made, okay, and then new body parts were made in below the head. So go ahead, pause it here and get your create body written down if need be. The next set of methods were fairly simple. These were our get methods that we needed and also our draw method. Okay, so again, nothing much to explain there. The draw method just simply loops through the entire list of body parts and draws each body part. So go ahead, pause the video here and get your draw method basically done. The move method was a bit more complex. Okay, the move method had to loop through all of the items in the list from back to front, so in reverse order, to move each body part based upon the direction of the previous body part in the list. So go ahead, pause the video here and get that filled out. The move method also had this detect collision function written in it. Now you have to make sure that you write that detect collision. The detect collision was a bit more complicated, so we'll see if we can fit that all on the screen for you. Okay. The detect collision allowed us to check to see whether or not we hit one of the walls or ran into ourselves. So go ahead and pause the video and get that in your file as well. And now that you're back, the last method was the append body part method, or the append body method. That allowed us to build a new part, okay, and put it in the right position based upon the last part that's currently in the snake, so the last item in the tail. So that's why we found out where all the last pieces were in the body part list. And then based upon its direction that it was heading, we put it in the correct location. So go ahead, pause the video here and get this copied in for you as well. All right. Once it's all said and done, make sure you test it, okay, and see that it's working appropriately. Once you know that it's tested and working appropriately, go ahead and turn it in to the assignment that this video is located in. Tomorrow, what we'll do is we'll try to get a mouse out there, which is just a blue square, and we'll run it over. And every time we run it over, that's what we'll actually call the append body part method. And then we'll start getting the snake game finished. So that's how we'll kind of put this all together. We're just building the objects to kind of see if they're working and testing them thoroughly as we go. So we'll see you guys tomorrow. Get this filled out and turned in.